Welcome back. So today we are taking a really deep breath and jumping into a source document called Toy Whippin' Tool Z.
And it is one of the most mechanically, well, detailed frameworks we've ever looked at.
It really is. Our mission here isn't just to describe it. It's to see how this system tries to impose this perfect digital legibility onto the messy reality of human movement and attention.
It's an architecture for total control, really. The entire foundation is a system that maps your specific body positions, we're talking hand grips, into a formal digital language.
Taking analog reality and, forcing it into a binary box.
That's a perfect way to put it.
And that box is the grip system. So we're dealing with 16 of these canonical grip vertices. They have these evocative names like piercer, viper, scathe.
Right.
So how does it actually encode something as physical as a grip?
Well, it uses a surprisingly simple 4-bit word. The grammar is LKLT, then a pipe, then RKRT.
Left knuckle, left thumb, right knuckle, right thumb.
Exactly. And each of those 4 bits is just a 0 or a 1. It defines the physical contact point. Knuckles are either blocking or blade.
And thumbs are pommel or hilt. So piercer being 0000 is just the digital signature for that one specific posture.
It's the digital fingerprint. Precisely.
Okay, so the body basically becomes an interpreter for this 4-bit language. But what about movement? You can't just jump between grips arbitrarily, can you?
No, absolutely not. And this is where the really strict constraints kick in. Movement between those 16 grips is governed by what the source calls the ladder law.
The ladder law.
Yeah, and it defines only specific legal edges. So, for example, piercer, which is grip 0, can only legally transition to viper or cascade. That's it.
If you try to jump anywhere else?
The whole sequence integrity just fails immediately.
And those legal moves, they're called gates, and they come with a cost. This delta epsilon, or how?
Right, this is like the financial ledger of the system.
What is that cost actually representing, though?
You can think of it as the system's attention currency. It's a coherence budget. Moving requires mental and physical rigor, and that rigor is measured with incredible precision.
And we see 3 of these legal gates. There's Nolix, which costs a massive +3.
Yeah, a huge cost. Then Slarnjok at +1, and Omvardis, which costs nothing, 0.
Why such a huge difference? What's a +3 transition that is 0 cost, 1 isn't?
Well, it represents the effort needed to maintain coherence. A 0-cost gate is a frictionless shift. A +3 Nolix, though, that demands maximum energy, maximum discipline to manage the drift.
And there's a rule about that.
A very strict one. Do not spend delta epsilon faster than coherence is maintained. If your budget hits 0, you just stall. The move might be legal, but you can't afford it.
We should also note the end of the line here, the scathe grip, 1111.
Yeah. Scathe leads directly to a gate called localaz, and that is the terminal state. It sets a flag, IAMOC, to false.
Hard stop, no continuation.
End of the line.
And this whole high-stakes process is overseen by the attention engine, running on this incredibly tight clock.
The clock is based on the golden ratio cubed, phi cubed, which ticks at about 4.236 hertz.
So, to put that in perspective for you, you have roughly 236 milliseconds, about a quarter of a second, for flawless execution.
It's a system designed to enforce absolute real-time discipline.
And that discipline needs verification. It's not enough to just move your hands.
No, this is maybe the most fascinating part. It demands multimodal coherence.
Okay, break that down.
First, the physical verification. The B0 finger contact bits have to be true in your actual body. Your fingers have to be in the right place.
But then you have the clip keyboard system, the vocal part.
Exactly. For every single grip, you have to speak 2 consecutive syllables. Always 2, left, then right.
And these are from a small set like KROA or KRI.
A very small atomic set. And you have to speak them inside that same 236 millisecond window. So the physical posture, the digital state, and the vocal utterance must all align instantaneously.
It's total control, enforcing coherence between the digital, the physical, the vocal, and even that energy cost. But every session has to end in silence.
That's the mandatory FF neutral rule. You have to end in silence for at least 2 ticks to clear the state. They don't call this failure, though. They call it mastery.
The ability to maintain control and then release it completely.
Right.
Which I think creates this perfectly legible world defined by these hard constraints and finite costed edges. And that brings up a final question for you, the listener. If mastery within this Toy Weapon Tools Z framework is purely about maintaining coherence logging, every tiny bit of drift as just data, not as meaning, what happens to human intuition, to improvisation?
You know, that impulse to move outside the bounds of those predefined costed edges.
Something to consider as you navigate the constraints of your own day.
Indeed.
Until the next deep dive.
So, for our deep dive today, we're getting into the Tesseract engine specification, and it's really this a wild blueprint for translating complex, messy human movement into perfect, trackable data.
It really is. I think blueprint is the right word, not manual. The sources we have, they're all about maintaining coherence and regulating attention states.
And the core of it all, this whole control system, it boils down to 16 specific grip states.
Right. Everything from piercer to shield to scathe. And each one is just a 4-bit binary code from 00000011.
Okay, let's unpack that binary structure because it's so elegant. It takes the position of your hands and just distills it down.
Yeah, to 4 bits, each hand gets 2. You have knuckles, where 0 is blocking and 1 is blade.
And then thumb, where 0 is pommel and 1 is hilt.
Exactly. So piercer, the 0000 state is your baseline. Knuckles blocking, thumb pommel on both hands. It's neutral.
And the complete opposite of that is scathe, 1111. That's fully engaged, knuckles to blade, thumb to hilt.
The entire physical vocabulary is just those 4 contact points.
So that gives you the inventory of states. But the really rigid part is how you move between them. You can't just jump around. There's this ladder law.
Oh, it's incredibly strict. It feels like physics being enforced by an accountant.
Yeah.
All transitions are governed by 3 legal gate semantics: Neelix, Omvardis, and Slarniok.
And this is where it gets really interesting for me. Each gate has a cost, delta epsilon.
Yes, and it's measured using Q16.16 fixed point arithmetic.
So for listeners who aren't, software engineers, what does that level of precision actually mean for a physical action?
It means they are tracking energy consumption down to these tiny, consistent fractions. Every little bit of spent energy matters. So Neelix, a corrective move, costs the most at plus 2.0.
Okay.
Slarniok, which is a bounded instability, costs plus 1.0. And then Omvardis, which is sort of a fluid implied continuation, costs nothing, 0.
And the core rule tying this all together is the use rule.
Right. You cannot spend delta epsilon faster than you maintain coherence. If you overspend, the system logs a penalty. It turns everything into a resource management problem.
And the absolute hard stop is scathe, gripid 15. Hit that, and it invokes the localized failure state. IAMOC just flips to false.
It's a mandated brick wall. That's the limit on the physical side. But then the specs mandate this whole other layer of verification.
The vocal bus, the CLIPKEYBOARD specification.
Exactly. This adds a critical layer of synchronization.
And the time law here is just. It's mind-bending. The CLOCK is governed by phi cubed, which is about 4.236 hertz. That gives you a 236 millisecond tick to verify every single move, vocally.
It demands total efficiency. You have to speak to full grip across 2 ticks, left-hand syllable, then right-hand syllable. There's simply no time for conscious delay.
And the syllables themselves are a completely closed system. There are only 8 possibilities.
Precisely. The syllable construction law dictates it's a knuckle root like KR, DL, ST, or VL.
Combined with a thumb vowel, so OA for pommel or IE for hilt.
And that gives you your 8 atomic syllables, KROA, KRI, and so on. They have to map perfectly to the physical bits.
And the transition law is the final check. When you move between grips, only one hand can change.
And that hand can only change one component, the root or the vowel, not both.
Violate that and you get a D, S, Y, and C.
So when you put it all together,
Yeah.
what do we got? It's a system that synthesizes precise movement, mathematical cost, and auditory verification into one coherent whole. The entire engine is built on that promise.
And no matter how complex the session gets, the destination is always the same. It has to end at FF neutral, spoken, NA, a forced reset.
So for you, the listener, think about this. If mastery in this system requires such perfect execution and calculation, why is the mandatory final step always a complete syllable verified release back to neutral? What value is being placed on unlearning the state you just spent so much delta epsilon to achieve?
So today we're diving into a really dense framework.
Hyperdense, I'd say.
Right, hyperdense.
Right.
It's the control specification known as Toy Weapon Tool Z.
And this isn't just theory, this is a protocol, and it was developed for very high stakes physical training.
Exactly, where everything, thought, speech, your grip, it all has to be precisely, mandatorily linked.
It's a complete control loop. It connects the physical states, binary code, what you say, and even the energy cost of moving.
So our mission here is to break that down for you. We'll focus on the system's foundation, the very strict laws of movement, and its real-time controls.
Let's do it.
Okay, so let's start with that foundation, the state space itself. We're talking about the 16-state grip table.
Which the sources call the grip vertices.
It's a grip vertices, right. These states, they span from 0000, which is piercer,
all the way to 1111, which is scathe.
And each one of those states is defined by a 4-bit binary code. It's basically a map for the exact physical position of your hands.
And the thing that's so fascinating is how simple the grammar underneath it all is.
Yeah.
You should think of that binary code as like GPS coordinates for your hands.
Okay, so what's the grammar?
It's fixed.
Yeah.
The grip is always LK, LT, RK, RK.
Left side, right side.
Exactly. And for the knuckles, LK or RK, a 0 means blocking, which you call KA, A1 means blade, or B.
Then the thumbs.
Thumbs, LT or ART, are 0 for pommel. That's A, and 1 for hilt, which is X.
So if you're in that starting state, Piercer, the code is 0000.
Right.
So that translates physically to KLK. Left knuckles blocking, thumb on the pommel.
And the exact same thing on the right hand. It directly links that abstract code to a very precise, verifiable physical requirement, a safe, sort of defensive hold.
Okay, so the starting point is defined. How do you move? Are the transitions just arbitrary, or is that all locked down too?
Oh, it's absolutely locked down. And this is where the real cognitive friction kicks in.
The ladder law.
The ladder law. It mandates that any movement, any change between these 16 grips has to cost something. It costs delta epsilon.
So an energy cost.
An energy cost. This is why the system's architects say it builds coherence. Movement has to be a calculated act of spending energy.
And these energy values, they aren't just random numbers. They're set in stone, precisely calculated.
Correct. You have 3 legal gates, or edge labels, that let you move. Think of them as friction gates.
Okay.
Nolix has the highest cost. It's set at plus 3.0. Slarongic is the standard gate. That costs plus 1.0.
But there's a 0 cost one, too.
And that's the crucial one, Vardis. It's the only way to move between states without spending that calculated mental energy.
And the core rule is?
What? Don't spend delta epsilon faster than you can maintain coherence. The whole sequence terminates when you get to Scathe, grip 15, through gate 7, which is called low class.
Wow. Okay, so to manage all of that, the cost, the sequence, the system demands what it calls phase discipline.
Yep, and that's dictated by a really structured clock, phi cubed. It ticks at about 4.236 hertz.
Which means each tick is only around 236 milliseconds. That's incredibly fast.
That speed is the tyrant, because your execution is tied to a vocal control bus they call the clip keyboard.
And the time law is rigid.
1 tick, 1 syllable, that's the law, 236 milliseconds per syllable. You need 2 of them in a row, left hand first, then right, to form a single full grip.
So you're moving fast, and you're speaking this code that maps directly to the physical grip you're making.
Exactly. The syllable itself is built from a knuckle root, like KR or VL, plus a thumb vowel, either OA or IE. Your speech literally becomes the key to your movement.
But the entire system just demands physical honesty.
This is the B0 rule, and it is non-negotiable. It states that your claim state is instantly false nullified if the physical contact verification isn't actually true in your body.
The finger contact bits.
The finger contact bits. So if you say the word for Scathe, but your fingers are not physically in that 11-11 position, the system just voids the action. No exceptions. None.
So when you boil it all down, what does this all mean? The whole thing is explicitly defined as a deterministic attention regulation system.
Right. Its promise isn't revelation. It's coherence. It forces this incredible precision across your thoughts, your speech, and your physical movements all at the same time.
It demands total verified control.
Total control.
But that brings up a really interesting final thought. The sequence terminates when you hit Scathe, the peak state. But the mandatory end of every single session is the forced termination back to FF neutral.
Spoken as N-A-N-A-N-A.
Right. So if mastery actually requires the ability to cleanly release all of that and reset back to nothing, what does that imply about the true value of reaching that terminal edge, that maximal heat of Scathe? Maybe the most important moves isn't reaching the top, but the final act of letting it all go.
Okay, so for today's deep dive, we're unpacking this really detailed specification for the C3BC system.
Which is officially codenamed Toy Weapon Tool.
Right. And this is not just some hardware guide. It's a systematic, deterministic engine built for attention regulation. So our mission here is to figure out how the system takes a physical grip, a physical movement, and just translates it into a fully codified 16-state logical machine.
With some very, very strict rules and timing.
Exactly.
And the first thing you see, what's immediately clear, is that it's a cognitive load map. It's just disguised as a geometry guide.
Cognitive load map.
Yeah, you have a 16-state grip table. Every single possible grip, from binary 0000 all the way to 1111, is defined by 4 binary contacts.
4 contacts, that's knuckle status and thumb status for both left and right hands.
Correct.
So you have these bookends, piercer at 0000 and skaith at 1111. But what do those contacts, actually mean physically? What is knuckles blocking versus knuckles blade?
It's all about stability. Blocking means your knuckles are oriented defensively, passively. It optimizes for retention.
Okay.
Blade means the knuckles are leveraged for dynamic control, for power delivery. And the same goes for the thumb vowels. Pommel versus hilt is about where your hand is anchored.
Which dictates your leverage.
Exactly. The system maps your physical state, your stability, your control directly to that 4-bit ID.
And I assume the movement between these 16 states is where the attention regulation really kicks in. It's not just random.
No, not at all. It's governed by what the spec calls the ladder law.
The ladder law.
You have to follow these predefined paths or gates, and every single transition has a calculated cost. They call it delta epsilon.
That's the coherence budget you have to spend.
That's it. It's what you spend to shift your focus.
Okay, let's break down those costs then. There are 3 legal gates: Nenolix, Slarniok, and Unvartis.
Right, and they're not equal. Nelix costs a hefty plus 3.0 delta epsilon. Slarniok is plus 1.0.
And Unvartis is free, 0.0. So what's the physical difference between a move that costs 3 units of attention versus one that costs absolutely nothing?
A zero-cost Unvartis move is an immediate, stable, sort of passive shift. It requires minimal muscle or focus change.
Got it.
But a plus 3.0 Nelix move, that's a radical shift in leverage or orientation, a maximal transition. It demands this huge, intense burst of cognitive and physical control.
And the core rule, the use law, is basically don't spend that budget too fast.
Precisely. Do not spend delta epsilon faster than coherence is maintained. It forces you into measured movement because you simply cannot afford the cognitive debt.
That focus on precision seems to be everywhere, even in the math. Why specify Q16.16 fixed point math for the cost? And why anchor the system clock using the golden ratio cubed?
Well, the fixed point math isn't about complexity, it's about stability. No rounding errors. For a system regulating physical action, that precision means reliable execution every single time.
And the clock, that 1533 giving us a tick of about 236 milliseconds.
That's about rhythm. It provides a non-integer, almost organic cadence. It ensures the sequence can't be rushed or done too slowly. It has to be done coherently.
And that coherence brings us from the numerical side straight to physical verification, the vocal syllable control bus.
Yeah, this part is fascinating. The rule is simple. If it can be spoken, it exists.
You have to explicitly track your state out loud. You have to be mentally aware of your grip ID.
It's a linguistic lock, the syllable construction law. Each hand speaks one syllable per tick. That syllable combines a knuckle root like KR, DL, ST with a thumb vowel, OA or IE.
So you are vocally verifying the state of your hands as you perform the grip.
You have to. And then comes the ultimate coherence check.
The adjacency law.
Yes. When you transition, only one hand is allowed to change its syllable.
And that hand can only change one component, either the knuckle root or the thumb vowel.
Never both at once. It's the minimal change principle, but applied to the body. It forces every high-cost move to be broken down into tiny, verifiable micro-transitions.
So the system ties it all together.
Yeah.
Physical action, numerical cost, vocal verification into this one single, tightly managed loop.
Exactly. Always demanding that physical check via what they call the B0 rule.
So you have this incredibly demanding system all for high coherence action. But what about the end? The sequence always concludes with skaith, 1111, but every session must end at FF neutral.
And FF neutral is declared vocally as N-A-N-A-N-A-N-A. A clean, unambiguous release is mandatory.
Which brings up a final thought.
It really does. And I
Yeah.
want to leave you with this question. In a system this demanding, this complex, what does it say about mastery when the ultimate goal isn't winning or persistence or even escalation, but a mandatory, clean release and the total dissipation of all that coherence you worked so hard to build?
Okay, let's dive in. Today's deep dive is pretty special. We're getting into one of the most specific, most rigorously defined documents we've ever seen.
We are. This is the TESSERAX engine clip keyboard spec.
And just to be clear for everyone, this is the core documentation for a proprietary, completely closed vocal control system.
Right. And it's designed for one thing: coordinating dual handheld weapon states.
What gets me right away is the tyranny of the clock. This isn't just a protocol, it's a rhythm.
It is. The whole system runs on this incredibly rigid time signature. We're talking about a clock frequency of roughly 4.236 hertz.
So breaking that down, you get about 4 ticks, maybe 4 actions per second. The fundamental time law is absolute.
1 tick, 1 syllable, that's the law.
And the sources really hammer this home. The system is 100% explicit. Every single state, every command has to be driven by a physical contact and a vocal output.
Nothing is symbolic, nothing's implied. I mean, if you haven't spoken the command that's tied to your exact physical grip,
It just doesn't exist in the system.
it doesn't exist. It requires a level of intentionality that feels almost, ritualistic.
So let's start with the atomic language of grip, the building blocks. A syllable is formed from 2 mandatory physical inputs.
Right. First, you have the knuckle root, and that's one of 4, and only 4, allowed physical anchor points on the hand. They're labeled KR, DL, ST, or VL.
And you have to pair that knuckle root immediately with the thumb vowel.
Exactly. And that just dictates the thumb's orientation. So it's either OA for pommel-oriented or IE for hilt-oriented.
You combine those and you get exactly 8, that's it, 8 atomic hand syllables, things like KROA or VLA.
A completely closed, immutable set.
Okay, now this is where the constraint starts to really feel practical. A full grip requires 2 consecutive syllables spoken across 2 ticks.
And the rule is fixed. Left hand always speaks first, then the right hand. No exceptions.
So with 8 choices for the left, 8 for the right, that gives you a total state count of exactly 64 full grips.
Just 64. And they have these defined names like piercer, viper, or scathe.
That feels like a tiny vocabulary.
It is. But it's incredibly disciplined. And if those 64 states are the vocabulary, then the transition law is the grammar. And it is mercilessly strict.
What does it say?
To move between any 2 full grips, only one hand is allowed to change its state.
Just one.
Just one. And even that hand can only change one of its components. So either the knuckle root or the thumb vowel. Never both components and never both hands at the same time.
Wait, hold on. Why is that constraint so extreme? That sounds like it forces a really minimalist mental path.
Well, that's the whole point. If you violate that grammar, you get an immediate system failure. It's called DESYNC.
And it just locks you out.
Blocks execution completely. The constraint isn't about speed. It's about forcing these intentional sequential micro-adjustments.
And every single legal transition has a cost.
Right.
Tracked on this very specific fixed point scale called delta epsilon.
Precisely. The spec literally treats your attention and your intentional movement as a quantifiable resource that you spend.
So these Geat triad gods in the document Alex Slarniak, they're just labels for the cost.
You got it. They represent different levels of effort. Nolifs is the most expensive transition, a cost of plus 3.0. It suggests you're fundamentally rethreading your attention.
And something like Slarniak is cheaper at plus 1.0. Vartis is the zero-cost transition, which implies you're just continuing a state.
Which leads to the core use rule. Do not spend delta epsilon faster than coherence is maintained. This engine is designed to regulate attention. That's its primary job.
Which makes sense of the end state. Termination, which is coded FF, is mandatory and explicit. It's just silence.
Silence lasting 2 or more consecutive ticks. That's it. It clears all momentum and resets the entire state. The document calls it a deterministic attention regulation system. It promises coherence, not revelation.
I think that's the key takeaway. It's all captured in what they call the integrity axiom. If it can be spoken, it exists. If it cannot be spoken, it does not exist.
And this commitment is guarded by a strict anti-compulsion rule. The logging is for calibration, to prove the effort was made, not for your own reassurance.
So no unscheduled checks. No, just to be sure, runs.
Strictly forbidden.
And this is the final, strange requirement. All sessions must end at FF neutral, logged as NA.
Yes, always reset to neutral.
So what does this tell us? When true mastery in a system this unforgiving is defined not by pulling off the action, but by the mandatory ability to immediately release all attachment, clear the state, and reset to neutral. What does that suggest about the ultimate goal of discipline itself? Something to think about. All right, so today we are diving into a document that honestly reads more like high fantasy than a piece of hardcore engineering.
It really does. We're looking at the TESSERAX engine 8 vocal syllable control basis.
Which is, what is that exactly?
It's the spec for a really rigid deterministic control system. It's built for dual handheld weapons.
And our mission here is to figure out how this thing manages to fuse vocal phonetics, a user's physical grip, and some pretty intense math.
Exactly. It's an architecture that forces just absolute discipline. It's like a machine that demands you prove you haven't changed your mind second by second.
Okay, so let's start with the beat of that commitment, the time law. The clock frequency is about 4.236 hertz, which is tied to the PHICUB constant.
Yeah.
Why anchor a weapons control system to a number like that, an irrational number?
Well, it's all about maximizing rigidity. You see, by using that specific constant, the system avoids any kind of common harmonic interference.
Yeah, every tick of the clock is distinct.
Perfectly distinct, non-elastic. And that one tick, it's about 236 milliseconds, has to equal exactly one syllable.
2 ticks, 2 syllables. That's one full grip. It sets this non-negotiable pace for any action.
And for tiny vocabulary, too.
Right. The syllable construction law seems almost ruthless. A syllable has to be a knuckle root like KR or DL, plus a thumb vowel, either OA or IE.
And those are tied to physical points on the weapon, the knuckles, the pommel, the hilt.
So that gives you, what, 8 total words? 8 legal syllables like KROA or VLIE for an entire weapon system.
That's the whole point. It's a constraint. They're deliberately few because they have to be perfectly discrete and physically verifiable.
So KROA isn't just a sound you're making.
Not at all. The engine is actively validating that your voice matches a specific grip on the vertices and the right jewel contact. It's not interpreting a command, it's confirming a physical state.
Which means the full grip space is also finite. You have 8 syllables for the left hand, 8 for the right, so 64 total states. Piercer, Viper, that kind of thing.
And since those are your only options, the system is obsessed with how you move between them.
Which brings us to transition integrity. This seems wild.
It is. Between any 2 grips, only one hand can change its state.
And not even the whole state, right?
Right. That hand can only change one component, either the knuckle root or the thumb vowel, not both.
Wait a second. So if I accidentally change both hands, or even just change both parts on one hand, the whole thing just bricks.
It triggers DSYNC instantly. Execution is locked.
That feels incredibly punitive for what could be a microsecond error.
It is punitive, but that's the design philosophy. The engine isn't built for flexibility. It's built to prevent any accidental state drift. Every single shift has to be intentional.
And the only way out is the FF state.
The only clean exit, yeah. You have to be silent for at least 2 ticks. It clears the state, resets the whole thing. It forces you to take a breath, a kind of digital meditation to recover.
And on top of all that, these actions are costed. They follow this ladder law. And every move has an expense called delta epsilon.
Yes, and it's tracked using Q16.16 fixed point arithmetic.
You don't need to be a math whiz for this, but basically, think of it as tracking numbers with extreme precision, right? No rounding errors.
Exactly. It's an accounting system for your coherence, for your expenditure of effort. And the rules are strict. There are only 3 legal gates, like Omvardis, which costs 0, or Nolix, which costs 3.
And your coherence budget, epsilon next, has to stay above 0.
You cannot spend effort faster than you maintain your discipline. Simple as that.
The whole system is anchored at this point of 0 coherence, Ayamami, which is verified by these 4 unarmed guidelines.
They're basically diagnostic checks to make sure the physical, vocal, and math all align back to 0.
What's so fascinating is how this spec just elevates accountability to an engineering principle.
Yeah.
Every syllable, every grip change is a costed commitment.
It forces intentionality. That's why those TESSERAX engine integrity axioms are so powerful. I claim no state without B0 verification. I claim no transition without E0 legality.
And my favorite, I treat drift as data, not destiny.
I end every session at FF neutral.
Drift is data. It's a mechanism that forces you to analyze every single failure. So for you listening, as you're managing information and commitments in your own life, what's your system? What's your structured, cost-accounted way of managing the inevitable drift in your own attention? What's your FF neutral?